So having seen these logical and physical equivalences, we're now going to work through an example query, and we're going to apply those equivalences to look at a whole space of different query plans for this pretty simple query. And the schema for this example is going to be our favorite sailors and reserves tables. In the reserves table, each tuple is 40 bytes long. There's 100 tuples per page, and there's 1,000 pages. You can assume that there are 100 boats in the reserves table. And we're also going to assume that every boat is equally popular. And that'll be an important assumption as we go through. In the sailors table, we'll assume that each tuple is 50 bytes long. We have 80 tuples per page and 500 pages. We'll assume there are 10 different ratings. And again, we'll assume that each rating is equally likely, which is an assumption that may not be true, but we'll assume it in our analysis below, as you'll see. We're also going to assume that we have 5 pages to do the join, so B equals 5. So here's a motivating example. The first plan we're going to look at for this query, which joins reserves and sailors, selecting to bid equals 100 and rating equals 5. The first plan is on the left here. It's a page-nested loops join of sailors and reserves, and the selections and projections are being applied on the fly in a streaming fashion to the outputs of the join. You can imagine this is not a very good query plan. How bad is it? Let's estimate the cost. We're going to scan sailors, that's 500 IOs. And because this is page-nested loops join, for each page of sailors we scan reserves, that's 1,000 IOs. So the total here is 500 plus 500 times 1,000, or 500,500 IOs for this query plan. Okay, so this is our straw man, this is our baseline. We're going to have to do better than this. Okay, it's not actually the worst plan. There are worse plans than this. We could do Cartesian products, for example. But it does miss several opportunities for both heuristics and things that seem sensible. Our selections, for example, could be pushed down to make the join cheaper. We didn't consider using indexes. We just used scans, and so on. So the goal of optimization is going to be to find faster plans that compute the same answer as this plan does.